Good evening, ladies and gentlemen. Welcome to TechGig webinar. Our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is second in the Android development series, and topic for today's webinar is Developing Java, Flex, and Native Application in Android. We are delighted to have Dr. V. Subramanian, Director and CTO, Sanasi Software Private Limited, as our guest speaker. Dr. Subramanian serves as the Chief Technology Officer at Sanasi. He possesses broad engineering and software development experience in the areas of virtual reality, human-computer interaction, simulator development with mobile applications, desktop and networking protocols, and application web services. Dr. Subramanian received his PhD in human-computer interaction, virtual reality, navigation aids for virtual buildings from University of Udine, Italy. Gentlemen, this presentation will continue for next 45 minutes and we'll take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Dr. Subramanian.
Is everyone able to hear me?
Yeah, we can hear you.
Okay, so very warm welcome. Yes? Sorry?
Yeah, please start. We can hear you and we can also see the presentation. Thank you.
Okay, all right, okay, all right. So a very warm welcome to all the people who are joining us today for this webinar. And I think over the next 1 hour we are going to have a quick look at how to build applications for Android in 3 different ways. For example, in Java and using C and C++, and of course the last option is going to be how to build applications using Flex, right? So let's get started. So quick checklist for application development in Java. So the first thing you will need is to have the JDK. I would recommend a version of 1.6 at least. Then you need to get hold of the Eclipse IDE, and the version I recommend is Indigo. Then you'll have to get hold of the Android SDK Manager. In fact, the version R16 is recommended. And of course, then it depends on how many Android versions, of the operating system that you want to target when you're building the application. So based on every single version that you want, you'll have to download as many SDKs. So for example, Android 2.2 is Android 8 in terms of the API level, and Android 10 is, for example, 2.3. So, depends on how many versions you're trying to build the applications for. And finally, you'll have to get hold of the what is called the ADT plugin for Eclipse. So once you install this plugin, Eclipse is customized, to help you in Android application development. So that's a checklist for if you want to build applications using Java. Let's move on. If you want to build applications using, just a moment. Okay, so here's the checklist for C and C++ development. It is almost the same as the previous case. That is, you'll still need to have all the items which I mentioned for developing applications in Java, but additionally for C and C++ based application development, you will need to have what is called as the Android NDK, and I would recommend a version of R7B. So that is the only extra item in this checklist compared to the previous checklist. All right, so that's for native application development. So let's move on to the final checklist, and this is a completely different setup, and this is for developing applications in Flash using the Adobe Flex SDK. So the checklist in this case is going to be 3 items. You'll have to get hold of the 4.6 version SDK of Flex, and you'll have to use the Flex Builder, which is in fact a product from Adobe. And finally, you will have to make sure that you have installed the Adobe Air runtime. It's called the Adobe Air runtime for Android. you can get this obviously on Android market. Okay, so that's, I think, the checklist for the comprehensive checklist for all the applications that we are going to look at in today's webinar. Right. So quick look at the application basics as far as Android is concerned, and I've been pretty careful to only describe those steps which are common to all three ways of building applications. That is, this applies to Java, this applies to building native applications, and this also applies to Flex applications. So the next set of ideas and concepts that we are going to discuss are pretty common to all the three approaches. So yeah, so let's get started with that. So typically any Android application that you build is made up of many screens. So you can think of an Android application as being built of one screen at least, but it is obvious that you can have complicated applications that have more than one screen. So, and there is a technical term for which is very specific to Android, and yeah, it is in fact the term activity, as you can see in the second point of this slide. So every screen within an application is simply called an activity, and obviously you take any Android application and it can have one or more activities, that is one or more screens. So here's a quick example, and it is in fact one of the most simplest and useful applications on Android, and which is the alarm clock. So if you observe the first image here on the screen, so I mean that's the shortcut to the alarm clock application. Once you click on it, it starts off and shows you a screen that looks like the second image, the one in the middle. So you observe that this is one activity. What you're looking at right now is one activity, that is one screen. But of course, the alarm clock application has more than one screen. So in this case, what happens is that once this particular activity is seen, then the application flow depends on how it is, I mean, how the application is built. So as in this case, as in the case of the alarm clock, you click on, for example, the 7 a.m. You click on the 7 a.m. item, and what you see is the next activity or the next screen. So as the arrows indicate, the red colored arrow indicates the forward flow of the application from one activity to the other, and the blue color arrow indicates the flow back to the previous screen when you click on the done button. So typically any Android application will have a flow that looks like this. So you start with one screen, and then you move to another screen, and then you move to another screen, and then you come back, and so on. So this is how it goes. All right, so let's proceed further here. So you can now imagine that once you have an Android system, I mean on a device or the emulator, whatever the case may be, so you can think of an Android system as a collection of applications. And just as I mentioned, any application is a collection of activities, that is screens. So overall, you can think of an Android system as a collection of many activities. All right. So the point is, it is possible that one activity inside an application tries to communicate or exchange data with some other activity inside the same application. Okay. Now that is one possibility, but there is also another possibility, and that possibility is that you can have an activity inside one application, but it is trying to communicate or exchange data with another activity from a completely different application. So for people coming in from a C or C++ background, or even Java, for example. So this is RPC, the concept of remote procedure call, or data exchange between one process and another. So this is more or less something on the same lines. All right. One final point here that I would like to make is, even though an activity can be thought of as a single screen within an application, but you must understand that it is actually two things combined together. There are two things combined together that form an activity, and those two things are: one is there is a layout. I mean, there is a graphical representation of how the activity and the components look like. Now that's one aspect. The other aspect is that there is quite a bit of back-end code that is involved. So the point is, these two things are put together and they become what is called as the activity, right? So quick example of the second point which I've mentioned in this slide, that is, one activity from inside one application tries to communicate with another activity inside another application. This is more or less on the lines of a remote procedure call. All right. So quick look here. I'm sure most of you might have at least used Google Maps or, for example, Bing Maps. So anyway, the point is that Maps as such is a standalone application. So you can imagine that the moment you start the Maps application, you get to see some kind of map, based on your GPS coordinates, based on your location. All right. So the point is, now it is obviously assumed that the moment you start off the Maps application from the phone, it is assumed that you already have the GPS. But it so happens in many cases that people actually forget that the GPS has to be on before you start off the Maps application. So just in case that there is a scenario like this, so what actually happens is that we have the Maps application, all right, and let us assume that you're currently looking at some map, which is the activity inside the Maps application. Now, inside the application, it is very simple to detect that the GPS is not switched on. At this point, what happens is the activity which is currently being seen, which belongs to the Maps application, it tries to invoke another activity which is outside of the Maps application. So you see, this is communication in a way from one process to another process, right? So you can see that in this case, there is an invocation of another activity, and you can see that activity on the right hand side of the screen. In fact, this is the settings module or the settings page from Android. So you can go here, the user can go to this page and he can switch on, for example, the GPS satellites setting, so that the GPS is switched on for the phone. And once this setting has been done, you can go back to Maps. So this is the way that you can have actually communication between different applications and different activities within applications. So I hope that is clear. All right. So the next, so in a way we have come to a certain conclusion there, and that conclusion is that any Android application is made up of multiple screens, and each screen is simply called as an activity. So you can think of an Android operating system, the entire Android system, as a collection of activities. Okay. So now the next concept that we have to understand, and again, as I mentioned, this is a generic thing. It applies to Java application development, it applies to C, C++, it applies also to Flex. So the concept is that of application permissions. So as the first point in the slide says, any Android application must specify the system level permissions that it requires to run successfully. So typical system level permissions, for example, can be let's say you have an application that wants to access the camera. So you'll have to obtain, your application will have to obtain permission to use the camera. Or let's say you have an application that depends on the GPS, so you have to get the permission for that. Let's say your application depends on the SD card, the micro SD card. So you'll have to obtain permission for accessing the micro SD card, and so on. So the point is that any Android application that is built needs to explicitly mention what are the system level permissions that it is expecting so that it can run successfully. So that's a very, very important point. Right, and as a second point says, so when the application is installed for the first time on a device, the user is presented with a list of all the necessary permissions which are required by the application. Let me quickly show you what I'm talking about. If you observe this, the screen here, there is an application, just a fictional application that I call as GPS tracker. So this application needs to have access to the GPS, and it also needs to have internet access. So you see here, as highlighted by the red colored rectangle here in this diagram, that Android is going to display this list of all the permissions which are required for this application to run successfully. So if the user is okay with that, he's going to click on install, the application installs, and it's going to work fine. But in case the user is not okay with that, so he can click on cancel and the application is not installed. Okay, so I think the concept of application permissions is clear. So the point is, when do you see the screen? When do you see this list of permissions? It is seen when you install the application onto the device. So that's that's the point there. So now continuing with the points here. So the point is, when the user has reviewed all the permissions and he accepts them, then the application is installed, just as we saw in the previous screenshot. And the policy I mean, this policy holds good for any Android application that is built in Java, C, C++, or even Flex. Okay. All right. So that is about application permissions. The next concept that we need to understand is something called as the application manifest. All right. So what exactly is the application manifest? So every application has this so-called manifest file associated with it, and what is inside the manifest file is in fact a lot of important metadata about the application itself. So think of this as the file system of an operating system, or the file system typically describes the layout of the file system, and it contains paths to the files and directories, so something on the same lines. So you can think of an application manifest as a file that describes in and out every detail of your application to the Android operating system. All right, and so the manifest file is typically in XML format. It's a custom extension of the XML format. So that is that is the contents of the manifest file are typically XML. All right, and most importantly, the manifest file contains the items in this list as I've mentioned here in the slide. So it requires, for example, the list of all permissions that are necessary for your particular application. For example, you might be looking out for GPS permission, you might want internet access, you might want access to the SD card. So the application manifest is the place where your application will specify that this is the set of permissions that I'm looking out for, right? And it additionally, I mean, apart from the permissions, you will also have to make sure that every single activity that you have within the application. So when I use the word activity, I obviously mean every single screen that you have built within your application. Every single screen has to be represented inside the manifest file. I mean to say there is a list of every single screen that you have within the application. So apart from that, one of those screens obviously is going to be the first screen that is seen by the user when the application starts. So that in fact is called as the entry point for the entire application. So so the entry point also should be mentioned inside the manifest file. And of course, finally, there is you can have, for example, some kind of constraint based on the Android version that is expected by your particular application. For example, let's say you built an application that is pretty recent and it cannot run on Android version 1.5 and below. So maybe you can specify what is called as a minimum SDK version. So you can specify that also inside the application manifest. All right. So this is the description for the application manifest. So let's go ahead now. A quick look at what happens in the background when you build and deploy Java applications on an Android phone. So typical flow goes this way. You have the Java source code, which is then passed through the Java compiler. It generates the bytecode, and then the bytecode executes on the Java virtual machine. But in the case of Android, there is a custom Java virtual machine implementation that is called as the Dalvik virtual machine. So in essence, what happens here is a slight deviation of the flow. So the Java source code goes through the Java compiler, and the Java bytecode is generated, and after this there is something called as a DEX compiler. The DEX compiler takes this bytecode as the input and produces what is called as the Dalvik bytecode, and then this Dalvik bytecode executes on the Dalvik virtual machine. So there is a quick difference between the way typical Java applications work on a desktop and Java applications working on an Android phone. All right, so quick look at what happens if you build native applications. So now, when I say native applications, there's a little assumption, and that assumption is that this is even recommended also by the Android developers website itself, and that is you can't actually build a full-scale or a full-blown application in C or C++. You will have to ultimately embed the C or C++ code which you have built inside an outer Java application. So that is the basic idea, as you can see in this diagram. So what typically happens is, now you can imagine that we have two kinds of source codes. So on one side we have Java source code, and on the other we have maybe C or C++ source code. So typically what happens is, when you have a Java program or you have an application which is built in Java, and then it has some part of its code in C or C++, then typically the C or C++ code will have to be compiled into a library, and then typically a dynamic link library, and then that library is linked to the Java application. So that way, when you actually depend, or when you actually invoke the code which is written in C++, the code is already available and it is going to execute smoothly. So this is the basic concept as far as the runtime environment is concerned for native applications. All right, finally, we look at the runtime environment for Flex applications. So in this case, whenever you build a Flex application, you can think of it as containing two parts. As usual, there is a graphical layout and there is some backend code which is associated with the graphical layout. So the graphical layout in the case of Flex applications is built in a custom extension of XML that is called as MXML. And the programming is typically done in a language that is called as ActionScript. So any Flex application typically is a mix of MXML and ActionScript. So once you have a Flex application built, you deploy it on what is called as the Adobe Air runtime. So, well, of course, it is obvious that the Flash player is ultimately the runtime which executes your application, but it is basically packaged inside something called as the Adobe Air runtime. And remember that it is a Flex mobile application. I mean, what we are talking about here is a Flex mobile application. But once you install it on an Android phone, it has full access to system resources. In a sense, it's not like a web application. I mean, it doesn't run inside a browser, but it is in fact a native application, so it has full access to all the system resources. All right. So that's about the runtime environment. Now let's start with the first trail. So this is going to be a quick look at how to build a very simple application in Java. Right. So obviously, for this, we are going to need the Eclipse IDE and we need to have the JDK installed. So assuming all that is done, let's get started. So if you want to build an application in Java, so what is it that you need to do? Well, obviously your application must have at least one screen, and that screen might have some UI elements like buttons or checkboxes, ready buttons, and so on. So typically you can build a screen using drag and drop. Now that is one technique, but remember that the screen is typically represented with XML code in the backend. So if you're good at XML, you don't have to use drag and drop. You can directly start writing code in XML as well. Now the other thing is there is another little technical term here, that is the term is called views. So any UI element that you take in Android is just called a view. So for example, a button is a view, a checkbox is a view, a radio button is a view. Any graphical widget that you take is typically a view. All right, so yes, I think we are through here. All right, so let's move on to the next slide here. So what are we going to do? We are going to now build a we are going to look at a very simple calculator application. And of course, it's not a pretty complex application. It's a pretty simple application here. The idea is that we want to understand how to go about building a simple Java application at this point. And so in this case, we are just going to have an application with one screen in it. I mean, one activity, right? So what are the steps we are going to follow? First step, we are going to take an Android project. We are going to create a new Android project in Eclipse. Then we are going to look at the layout for this particular project. And obviously the layout, when I use the term layout, I'm talking of the screen. So this application is going to have just one screen, and that one screen, will design it the way we want. And of course, what is the next set of steps that are involved? There is, remember, as I mentioned, every activity has two aspects. One is the layout and then the backend code. So we have already talked about the layout. Now, inside the backend code, there are certain steps that we have to follow. And ahead we'll look at what those steps are. All right. So quick look at the way the project structure is organized when you set up a new Java project. So in this, in this diagram, you see that here we have a bunch of inbuilt libraries. Okay, so this depends, the libraries will depend on what Android version you're targeting. For example, in this case it is 2.2. It could have been 2.3 or 4.0, whatever the case may be. Then there is a subfolder that is called as SRC. So it is obvious that all the Java source files will be present in this particular folder. Then there is another folder that's called as gen, which contains some files which are generated automatically. All right, then here is the most critical file that is called as a APK. So it is short for Android package. And in fact, this is the file that must be installed onto the phone. So that is the ultimate output of the entire application building process. Right. Then here is the layout. Remember, I was just talking of the layout. So the layout folder in fact contains one XML file for every screen that you find within this particular Android application. Okay, and then of course the famous manifest file which we discussed in quite a bit of detail previously. Right. So this is how a typical Android Java project is structured. Okay, so now here's a quick set of screenshots so that that you can look at, and because since we are short of time, so we already have the project ready, and we'll look at the project. But in the meantime, just a quick look at what are the steps involved. So you start off, you start Eclipse, then you click on File, New, and Project. Okay, so once the wizard pops up on the next screen, so click on Android Project. So once that is done, you specify a name for the project, and you pick what is called as the build target. Which version of Android are you trying to target? 2.2, 2.3, 4.0, whatever the case may be. So in this case, we are targeting 2.2. Then make sure that you have a name for the application, and please specify a package name also for the application. That's it. So you don't have to do much apart from that. Okay. So now let's quickly look at this example in the emulator. All right. So all right, so here is the application, and we have already, okay, so this is the screen. This is how it looks like. All right, so just a moment. Okay. All right, so you can see it's a pretty simple calculator that contains, for example, 2 input fields in which the user can type numbers and then click on add, subtract, or multiply. So it's pretty straightforward. Okay, so let's quickly look at this example live on the emulator. All right, so in this case, let's say put in say 12, 34. I try to add this. Okay, this result is shown here in what is called as a toast. So it's just a little pop-up window. Okay, here I hope you're able to see the result now. Let's try to multiply these numbers. Okay, so this is the calculator application running on what is called as the emulator. It's a virtual Android phone. So that is what is the emulator. This is the screen, the emulator that you're looking at. All right. So now back to the presentation. Just a moment. Okay, let me see. Okay. So now just a moment. Okay, I think we now need to look at the source code. Quick look at the source code of the calculator application. All right. So okay, so you can now see that all right, this is the screen. As I mentioned, the layout folder inside the res subfolder of the project contains an XML file for every screen within the application. Now, as I mentioned, this particular application contains just one screen, that is one activity, and let us have a look at what it looks like. Okay, here it is. So let's zoom in. There, it is pretty simple. It's in fact, it just contains 2 text fields and 3 buttons here. That's it, as simple as that. All right, so this is the graphical representation of the screen. But if you actually switch to what is called as the XML view, all right, so you see this. So this here is the XML representation of the screen that you see here. So that is the basic idea. All right, so now corresponding to this screen, this is the backend Java code which is associated with that screen. So both these things put together, that is the screen here and the Java code, both these things put together become one single activity. And so for the purpose of this simple application, what we assume is that there is just one single activity. That's it. So you can see here, so this is basically a custom class that's called as calculator activity, and it extends the base class that is called as activity. And there is an on-click listener. So why do we need the on-click listener? It is for the button, because you might click on any of these buttons after having specified the 2 input values. So we need to find out which button has been clicked on, obviously. So we need to find out if you have clicked on the plus or the into, for example. Okay, so now if you observe the steps here, so we have 2 very important steps. Sorry, in fact 3 important steps. So the first step is where we associate this Java code in the backend with the screen here. Okay, so that is the line here. If you observe, there is something called as a set content view, and then we have particularly mentioned main. In fact, that is the name of the layout file. So that way, this particular Java class is associated with this particular screen. So that is the idea. All right, so that's the importance of this line. The second step, we are going to register button listeners. So that way, we know which button is clicked at what point. Right, and the third step, we are going to just obtain references to these two text fields. So that is the third step. Okay, so what we do is we register the button listeners that is in this code here, and we obtain the references to those two text fields. All right. So when the button is clicked, there is a function called, there is a method called execop. So this execop is actually going to do the backend processing. So it is pretty straightforward. What we do is we find out, when the button is clicked and the runtime, the Java runtime calls this particular event handler. Then we find out what button has been clicked, and we try to obtain the text property. The text property is the label which you see on the button. It can be, for example, the plus or the minus or the star. All right. So based on what symbol is found on the button which was clicked. So what we do here is pretty simple. We convert. Remember that the text fields here, the contents inside the text fields are strings. So those strings will have to be converted into integers. That's pretty obvious, right? So once we have these two integers, then we either add them or we subtract them or we multiply them. And after that, there is something called as a toast, as I mentioned previously. It's a little pop-up window that is displayed for, in this case, 5,000 milliseconds. It's 5,000 seconds. So this is pretty straightforward, all right? So I hope this example has been a bit useful for you to understand how a simple Java application can be built and deployed onto the emulator. All right. So now let's spend just 2 minutes to have a look at the same application deployed onto a real Android phone. Okay. So let's So there is a tool for people that might be interested. There is a tool called as the DDMS. So this particular tool helps you to observe the screen on a real Android phone. So in this case, we have a Sony Ericsson phone connected to this laptop. So let me start up the screen capture. Okay, as you observe here. So this is the screen of the phone. All right. So let's start up the application. Just hang on. Okay. So it's upside down. Yeah. All right. So here is the application. So let's now look at. All right, so if you observe here, this is the application already installed on the phone. So I'm going to start up this application right now. And if you observe, the screen looks pretty much the same as in the case of the emulator. Let me rotate the display. Hang on. All right, sorry. Okay, all right. So now if I click on the first text box, okay, so that's the first value, and then I click on the next text box. So that's the two text fields having the values. And now let's click on, say, the star. Okay, there's the result. That's 408. So you can see that we have successfully been able to install this application onto an Android phone. Now we have obviously seen both the deployment scenarios. We have had a look at the application being deployed on the emulator, and also we have seen it being deployed on a real Android phone. Okay, all right. So that, I think, concludes the Java example. Let me see if we have missed something. All right, these are screenshots of the same of the device that we have just seen. All right, so I think that's the end of trail 1. So we have successfully been able to understand how a simple Java application can be built for Android. Okay, so now the next step, let's now look at a native application. Now when I say native application, as I mentioned, obviously the wrapper application, the main application is going to be built in Java, but there are going to be certain pieces of the application which are going to be built, in this case, C, but obviously it could also have been C++. All right, so what is it? What are the prerequisites for this particular application that we're going to look at now? We obviously still need to have Eclipse, and we still need to have the JDK already installed. All right, so let's move on. So in this case, here's a few notes which I have actually obtained from the Android developer website. So what exactly do we mean by native applications for Android? So the point is that you can actually build certain pieces of code that I mean you might want to write in C or C++ for certain reasons. Now those reasons may, I mean it's entirely dependent on the situation. There's no hard and fast rule, but it is entirely a judgment that is left to the developer. So the point is, I mean, Java is definitely a powerful programming language, no doubt about that, but there are certain scenarios in which maybe you already have some libraries or you already have some code that is built in C or C++, and it's pretty stable. So the point is, why would we want to port it over into Java and then try to introduce bugs into the application? We don't want to do that, right? So the point is, you can actually take the C or C++ code which you already have and then, you know, integrate it into an Android application. So that way you actually can reuse the code which is already well built and well tested, right? So the point is that typically any component that is built in native code is usually embedded inside a Java application. So that's the point. So the point is that just because, I mean, let's not be under the assumption that just because you have built the application using native code, then it's going to be, you know, it's going to give you a performance boost. That is not the case. In fact, it might also slow down the application. So it entirely depends. It entirely depends. All right. Okay. So let's now move on to this particular example. So in this case, well, ideally, this can actually become an application which you can tie in with a GPS, but in fact, due to lack of time, we have not been able to do that. But anyway, let's have a look at the application itself. So the application is going to be pretty simple. We have a two-dimensional coordinate system, and we have two random points inside the coordinate system. So one of these points I call as x1 and one of these points I call as p1, the other I call it as p2. So what we are going to try and do is, you know, use the standard distance formula to calculate the distance between these 2 points. Now it is obvious that if we can actually tie this into the GPS, we could actually have one stationary point and one moving point. So you could build this application, put it on the phone, put it in your pocket, and then, you know, travel, and you can expect to actually have a real-time update of the shortest distance between you and the target point. All right. So now let's move on to actually, you know, let's get down to developing this particular application and having a look at it. Again, in this case, just to keep it simple, we are only going to have, again, just one single screen, that is one activity. All right, and it is obvious that part of this project will contain code in Java and part of it will be in C. All right. So what are the steps we are going to follow? We are going to create a new Android project, and in fact, that is pretty much the same as in the case of Java. You remember the screenshots, right? So it's going to be more or less on the same line. So you create a new Android project, then you specify what is the build target, I mean which version of Android it is, 2.2, 2.3, 4.0. You specify a package name for your project, and you finally specify a project name, and you know, the Android project is created automatically in Eclipse. All right, so once that is done, in this case, what we are going to do is we are going to again go back to the main screen, the layout, and we are going to quickly build it, and then we are going to link it as usual with the backend Java code. Remember that every activity has two things inside. There is code and there is the layout, right? So once we build the layout, we are going to go back to the Java code, then we are going to link these two things up, and finally we are going to you know, execute the application. So that is the basic idea. All right. So quick look at the Java project structure in case we are talking of, obviously in this case we are talking of a native application, right? So as I mentioned, you can clearly distinguish between source code that is in Java and source code that is in a different programming language like C or C++. All right, so quick look at the structure. So in this case, as usual, we have a src folder which contains the Java source files. Then we have the usual Android libraries. So in this case, it is 2.2. Then here is a quick look at the bin folder. In fact, it contains, as usual, the APK file. Now remember that inside the APK file, in this case, we have two different kinds of code which have been built from two different programming languages, that is Java and C. Okay, then here is the difference compared to the previous Java project, and that is a subfolder with the specific name JNI in lowercase. Now for people who are already familiar with this is the Java native interface. All right, so the point is, inside the JNI folder there are two specific, well, there is at least one specific file that must be available in case you want the project to work correctly. Okay, and that file has this specific name. It's called android.mk. There are some settings inside this particular file, and of course there is in fact the C file itself, which contains part of this the project's code. Right, so we have got the source code in Java, we have got the source code in C. Finally, ahead we look at one very important step, and that is using a tool called as NDK build. Now this NDK build tool is part of the Android NDK. Remember the checklist? I had mentioned that when you're building a Java native application, you need to make sure that you have installed the Android NDK. Okay, so when you're building Java applications, you need to have just the SDK installed. But when you are building native applications, you need to have not just the SDK but also the NDK installed. So one of the tools inside the NDK is something called as the NDK build. Okay, so when you use this NDK build, when you specify this particular project as the input to the NDK build tool, it is going to generate what are called as .so files. In fact, these are, if you remember one of the diagrams which I had described a few minutes ago, it is in fact the dynamic link library, which is in fact the which has to be linked with the application. All right. So now, so what are the steps that we are going to have here, especially as far as the C code is concerned? Okay, we have already seen what are the steps involved as far as Java, the Java part of the application is concerned. So in this case, you will need to have, as I mentioned, a J and I folder inside the project structure, and make sure you have the android.mk file inside it, and of course the source code which you are going to build in C. All right, then don't forget to invoke the ndk build command. So once you do this, and you should also do it from the project folder. Okay, so anyway, we'll have a quick look at where you can actually find the ndk build command. Okay, and then the ndk build is going to generate the libraries which will be linked during runtime to the Java application. All right, so quick look at the distance calculator program, but before that, let's have a quick look at the Android NDK. So just give me a moment. All right, so okay, so in this case on my laptop here, what I've done is I have installed. Sorry, it's it's here. All right, so in this case, what I've done is this is the folder. Okay, so okay, sorry, I think it's not on this machine. All right, no problem. So anyway, the point is that we have the Android NDK, and the Android NDK is in fact you can download it from the Android developers website. Yeah. So okay, anyway, so let's now move on and try to run this particular application. Okay, so first step, we're going to run this as usual on the emulator. So here is the calculator application. I'm going to close that, and let's now start the distance application, right? Okay. So let's just give it a moment. Okay, I think there might be a problem with Eclipse. All right, so it's not an issue. Okay, so tell you what we can do is we already have this application installed on the device. So let's have a quick look at that. So yeah, so all right, so let's look at the application. Okay, so if you observe, we have a distance icon here down below. So that is the distance calculator application. Now let's try to run that. So once we run this, this is how the screen looks like. Okay, so the first two input fields are the x and y coordinates of the point P1 inside the two-dimensional coordinate system, and then the point P2. So yeah, so let's try to fill in the values for P1 and P2. Okay, so let me say I want 10, 10 for x and y for P1, and let's put in maybe 20 and 30 for P2. Okay, now once I'm done with this, so let me hit the calculate button, the calculate distance button, and there it is. Okay, so this, sorry, I think we'll have to rotate the screen. Okay, just a moment. Yeah, so let's wait just a moment. Okay, so Sorry. Okay, so here is the screen. All right, so when I hit the, there it is, there is the distance. Okay, so this is pretty straightforward. I mean, it's the standard distance formula. It's not rocket science. This is something pretty simple. All right, so now let's have a look at the project code. Now that we have already seen this application deployed onto the device, so let's go back and look at the source code for the project, give it a quick run through and try to understand how it is built. All right, so let me start up Eclipse again. Okay, so there is Eclipse. So here is the distance project. Let me open up that. So now, as usual, inside the res subfolder of this project, we have the. Sorry, is there a problem with the audio? Okay, I hope things are fine. All right, so let's continue. So in the res folder, we have the layout subfolder, in which we have the screen for this particular application. As usual, it's just one screen. So I mean, we are trying to keep things simple here. All right. So just give it a moment. Let the application open up. All right. So that's the screen which we have just seen before this. So let me zoom in. There it is. This is what we have seen on the phone, right? Okay. So and what is obvious is that this screen, even though this is how it looks visually, has a XML representation in the background. I'm sure most of you have already guessed this by now. So now let's go back into the Java code. Okay, this is the Java code corresponding to this particular activity. Okay, so as usual, what we are going to do is obtain references to all these text fields. Remember, we have got 4 input fields here, 4 input fields in which you can have 4 different values. So what we are going to try and do inside the Java code is we have a method called get input references. So inside the get input references, all we do is obtain references to these 4 fields. Okay. Now, once that is done, as usual, we are going to register a listener for the button, and so that we know that when the button is clicked, we know that the button has been clicked. All right. So once the button is clicked, what we do here is we call the get input values method, and you can guess what it does already. So what it does is it's going to extract the values for all the 4 text fields, and it is going to convert them into double. Okay, it's going to convert them into double values. All right. Then what we do after that is we call a function that's called as calculate distance, and we simply pass it all these 4 parameters. Okay, and of course you can imagine that inside the calculate distance method, we have the standard distance formula being applied. So now the surprising part is this line here. You see this? This is the this is not in fact the definition of the function itself. It's in fact a declaration, and you can see the word native here. What that means is this particular function is not written in Java. It is in fact written either in C or C++. Okay. So now let's have a look at the C code itself. Now, as I mentioned, the C code is found inside the JNI subfolder of this particular project. So let's double click on that. Sorry, just a moment. Yeah, okay. So let's open up this inside. Okay, here it is. It's pretty simple. So this is good old C code. So as usual, we have got a bunch of hash includes, and one of the most important hash includes is the jni.h. All right. Okay. So now, if you observe the name of the function here, it is calculate distance. Okay. So in this case, there is a certain naming convention that you will have to follow, and that naming convention goes like this. Okay. First we have Java, and then com Sanasi in this case. So which is in fact the package name, if you observe here, of the Java code. Right, then we have the distance activity. In fact, this is the name of the Java class. So I hope the naming convention is so far clear. Then finally, we have the calculate distance. In fact, this is the name of the Java method. So it is pretty straightforward. And of course, we have so many arguments to this particular C function, of which the first 2 arguments are mandatory, and these are expected anyway. After this, we have a bunch of arguments that are very specific to this particular case. So if you can observe back in the Java code, we have got 4 different parameters that we are passing to the C function, and of course those 4 parameters are received here. In this case, we call them as double. I mean, the Java data type is called as double, but in the case of the C code, it's called J double. Okay. So, and of course, this is pretty simple. You can see all we have done is, find out the difference of the X values and the Y values. Then we have just calculated the square root, and we are just returning the value in the form of a double. So it's pretty straightforward. Okay. So now, yeah. So this is the application. So this we have observed the code written in Java, and we have also observed the code that is written in C. Okay, one final thing that I would like to make sure that you have noticed, and that is these 3 lines of code here. That is, in fact, what we are trying to do is, remember I was talking about the C code getting converted into a dynamic link library and then getting linked into the Java application during runtime. So that is thanks to this particular line. So you can see it is called a system.load library, and then it is the C file that we have built here. So that gets linked into the Java code. Okay. All right. So I think that is the end of the second trail. Now let's move on to the final trail, which is going to be Flex. Okay. So let's just move on. Okay. So this is the third trail. In this case, you will need to have the Flex Builder. We are not going to use Eclipse for this. Obviously, we are going to use Flex Builder. Interestingly, Flex Builder is actually a custom-built version of Eclipse itself. So in a way, we are deep down, we are still making use of the Eclipse IDE itself. Okay, so let's move on. So what are we going to do again? As usual, we are going to build screens. You can build a screen using drag and drop as usual, or you can also, if you're good at writing XML code, you can also start writing code in XML. All right, so as usual, standard widgets are provided in Flex, and if you're good at XML code, as I mentioned, you can directly start coding in XML. Okay, so the point is, Adobe has a very custom version of XML for this particular purpose. I mean, for building graphical interfaces in Flex. So that is called as MXML. Okay, so you can use MXML to visually represent the screen. So it's more or less on the same lines as the layout that we have seen for the Java project. Okay, and of course, the programming is done in a language that is called as ActionScript. Okay, all right. So let's move on to the next slide. So what is the strategy what is the project about? What is the strategy that we are going to take to build this particular project? So what we are going to do is we are going to build a simple Flex application that will enable the user to take photos from a mobile phone which has a front and back facing camera. So in this case, it's pretty specific. So you need to have a mobile phone that has both a front and back facing camera. So if you want to run this particular project. All right. So as usual, we are going to try and keep the example simple. So we'll just have one screen, and in that screen we are just going to have a live preview of the front camera or the back camera, depending on whatever the case may be. And so yeah, so that is the idea. And well, the application finally what it does is it's going to have a button. When you click on the button, the photo will get saved into the micro SD card which is installed on the phone. Okay, so that is the strategy for this particular project. All right, so now let's have a quick look at what we're going to try and do here. So what we're going to try and do is we are going to set up a new Flex mobile project in Flex Builder. Then we are going to, as usual, build the layout, and then we are going to write the corresponding ActionScript code corresponding to that particular layout. So inside the ActionScript code, what is the set of things that we are going to do? We are going to set up what are called as the camera and video objects. Then we are going to write a bit of code that is going to toggle between the front and back camera when the user is going to click on the toggle button, which you will see a bit ahead. And of course, then we are going to convert, once the user clicks on the button, we are going to convert this raw image into JPEG format, and finally we'll try to save it into the micro SD card. Okay, so this is the set of steps that we are going to follow for this particular project. All right, so quick look at how the screen looks like. So you click on File, you start up the Flex Builder application, then you click on File, New, Flex Mobile Project. Okay, then the next screen, you're supposed to mention the project name here and the path to the project, and if you prefer any particular version of the SDK, the Flex SDK, I mean to say. So in this case, it's going to be 4.6.0, the latest. And all right, so the next screen for the project, the project wizard is the mobile settings screen. In fact, you can actually build Flex applications that can target more than just the Android platform. As you see here, you can target, for example, the BlackBerry operating system, or you can also target the iOS devices, iPhone and iPad. So in this case, we are going to just look at Android. Okay. So another important setting that you might want to specify is the application DPI. It's a dots per inch, makes the application look much more crisp when you put it onto a device. And of course, if you want the application to go full screen or you want it to be in windowed mode, you can specify with this checkbox here, and then you can specify, for example, how your application looks like. Is it based on views? Is it based on tabs? Or is it just, for example, a blank application with just one screen? So in this case, we are just going to take an application that has one screen. I mean, just to keep it simple. All right. So as I mentioned, you remember we were talking about application permissions when we discussed the initial part of this webinar. So in fact, we are at the same point. So even when you're building a Flex application, you must make sure that your application is explicitly specifying what permissions it needs to run successfully. As in this case, I want to have internet access. I want to have the ability to write to the external storage, which is the micro SD card in this case. And for example, I obviously need to have access to the camera. So these are the application permissions which my particular application is going to expect. All right, so moving on. Okay, so I think it's time to look at the code itself, and I think we can look at also the demo on screen sharing before we jump into the source code. All right, so let's start up the phone again. So let's look at the application on screen sharing. Okay, so just give it a moment. All right, so we have the phone online. So just a moment. Okay, I think we have a crash. Let me try to restart. Okay, one thing is pretty obvious, and that is the, sorry. Okay, yeah, okay, sorry. I think we already have one instance of the DDMS running. So let me now try to start up the DDMS again. Sorry about the glitch. So just hang on for a moment. All right, so one thing that I would like to mention here, and that is if you want to practically build and deploy Flex applications onto an Android phone, you must make sure that you have a ARM V8. It's, I think, ARM V8 Cortex processor. So you'll need, I mean, you'll have to make sure that you at least have a V8 or a V7. So that's the one thing that you need to keep in mind. And please also keep in mind that you need to install, when you'll have to download and install Adobe Air from Android market. So once you have installed Adobe Air, then your I mean, you can actually run the application. All right. So there is the screen sharing, and thankfully it has started off right now. Okay. So now let's look at the application. All right. So you see the camera demo debug. Okay. So I'm going to click on that. So that is the Flex application that we have built, and what you see right now, I think we can rotate the screen. Okay. So I think yes. So this is in fact a live preview of what is being seen by the phone. Okay, so this is a live preview. All right. So the point is, this is not the default camera application. What you're looking at here is a Flex application. Okay, so from inside the Flex application, we are able to preview camera. Right. So now, if you observe, there is a toggle button. I'm sure at this resolution it's difficult to, yeah, okay, sorry. All right, so there is a toggle button. So once I click on the toggle button, you're going to have a look at the presenter of this webinar. I apologize for that. All right, so once I click on the toggle button, there it is, that's me. Okay, so hello to all the viewers again. All right, so let's toggle again. So that's it. And once I click on the capture picture button, so this is going to get saved onto the SD card of the phone. I'm not sure if you have a SD card installed, but in any case, all right. So once you click on the capture camera button, sorry, the capture picture button. So yeah, that's it. So I think yeah, all right. So that's the Flex application. So now let's quickly go into the source code and have a look at it. All right, sorry. So we don't need Eclipse for this. We have to start Flex Builder. All right, so just give it a moment. This is a pretty heavyweight application. Okay, let me quickly go back, see if we have missed anything. No, I think this is fine. Okay, so quick look at how you actually can deploy a Flex application. Okay, so in this case, what we do is we specify something called as, okay, sorry. Okay, so you specify something called as a run configuration. Just give me a second here. All right, yeah. So as you can see here, this is a list of applications that we have built. But anyway, so the point is that you need to specify. I mean, when you actually deploy a Flex application, you need to specify what is called as a run configuration. Okay, so the run configuration offers you two options as usual. One is the emulator. As usual, there is an inbuilt emulator even for Flex Builder, and two, you can actually have a device connected to the computer and you can actually deploy it on a device. So the typical run configuration provides you with these two options. You can run on the emulator or you can run on a device. All right. So in this case, what we are going to try is we are going to pick on device. Okay. So once you pick on device, you can actually deploy this application onto a device that you might have already connected to the computer. So in this case, we already have a phone connected to the laptop here, so it is directly deployed onto the device, and which we have already seen. Okay, so yeah, okay, so I think yes. Okay, so we are through with the slideshow. Let's now just spend 2 minutes on the code here and quickly analyze it. All right, so this is the camera demo project that you see here, and it is structured this way. So there is the usual SRC folder which contains, in this case, obviously this is not, I mean this is Flex, so it contains a file that is called as MXML. I mean it has a MXML extension, so this is the place where you have all the code, okay? And then there is the Flex library itself, the runtime. All right, then there is the bin debug folder and the famous APK file which is actually deployed onto the device. All right, so quick look at the screen. So this is how it looks like. So if you remember the screen, even though it is designed using drag and drop, always remember that in the back end there is an XML representation for the layout. Okay, so as you see here on the screen, we have a capture picture button here, and there is a toggle button which I use to toggle between the front and back cameras. And I think this, okay, it's not seen, but you have an invisible object here which actually renders the video for the camera from the camera. All right. Okay. So quick look at the source code, which we'll try to understand here. So so yeah, as usual, two things that you'll have to understand. One is this code which I'm highlighting right now on my screen. This is the graphical code. Okay, so this is the XML code which I was talking about. So this is the MXML code which I was talking about, and this is in fact the layout, what you see here graphically. Okay, so this is the graphical part of the application, and then below we have something called as an FX script node. But if you observe inside this, the code which I'm highlighting right now, this is in fact action script code. So just like in the case of the Java projects, we saw that the XML was used to design the screen, and then Java was used as the programming language, or in the case of the native application, we also used C as the programming language. So in this case, the programming language is ActionScript. Okay, so pretty straightforward. So what we do is, first we try to initialize the settings for the camera, and that is this particular set of code that you look at. And yeah, so then there are two cameras. Remember, I mean, we assume that the device has two cameras. There is a front camera and there is a back camera. The front camera is represented as 0 and the back camera is represented as 1. So you can imagine that when I click on the toggle camera button, I simply call this particular switch cam method, and the camera gets switched between the front and the back cameras. And then there is a method here called as attach camera. So that that takes care of the attaching the camera to the live preview on the screen. All right, then once I click on the capture picture button, so then there is a function called as getPic, which I call, if you observe here, this is it. Okay, this is the button for which the label is capture picture. So you can imagine that this is the button which you saw there on the top right hand corner of the screen, and when that button is clicked, this is the event handler which takes care of the processing. So it's simply a method called as getPick. So let's now look at what getPick does. So the point is, it's just going to create what is called as a bitmap data object, and it simply draws, it renders whatever is the frame of video which is right now being previewed by the camera. So pretty straightforward. Then what we do is we call a method that's called as a write file, and we pass it the bitmap. Okay. So inside the write file method, what we do is we have a JPEG encoder class that is already inbuilt in Flex. So we take the JPEG encoder, we set it a compression rate of we set a quality rate of 100%, which means it is lossless. Then all we do is encode the bitmap data into simply a byte array, but in fact you can imagine that the byte array actually contains JPEG data, okay, in the JPEG format. All right, and after that, what we do is we simply create a file stream object, and the file stream object is, you can imagine that these 3 lines of code actually do the writing to the SD card. So what happens in this case is we simply create a file stream. The snapshot.jpg is going to be inside the documents directory. You can actually browse this on the phone after you capture a screenshot. So you can imagine what the up the file in write mode, then you simply write the JPEG data into the file and you close the file. So it's as simple as that. All right. So I think that brings us to the end of the 3rd trial, and in fact that brings us also to the end of the webinar. So yes, so yeah, so I think we are through with that. So yes, so I think we are done. So thanks a lot, and I think I can actually take any questions from the audience at this point.
Questions are already shared.
Okay, so just a moment. Right, let me check. Well, we have quite a lot of questions. I'm sorry about that. Go well. Actually, you can use any version of Eclipse that is pretty recent. So I would specify you can go with, for example, Eclipse Helios, but you could also use, for example, Eclipse Indigo. So I mean, there's no particular reason for having used Eclipse Indigo. I think I understand where you're coming from. So it's a checklist, right? So it is all I've recommended there is the most recent software. That's all. You can actually play around with it. Go back to older versions. Google or the Android developer platform can actually trace the application back to you as a developer. So that is why the need for a digital signature. So it kind of makes your application unique. So that's the idea. All right. So can the content of Android manifest file change dynamically while the application is running? No. It is a static file and the contents are static. What I mean to say is once the contents are generated and that too automatically, it is closed. I mean, it's a sealed file. You are not supposed to change it. That's it. So yeah, so you can't change it. And what is meant by metadata? Metadata is in fact it's a very generic term. So it is in fact description. The manifest file contains data about your application. Okay, so in short, it contains every single detail of the Android application. So for example, how many screens it contains, which of those screens is the main screen, what is the minimum SDK version of Android that you're expecting on the device on which you're trying to deploy the application, so on. Okay, so settings like this. So that's what I meant by metadata. So will the manifest file contain the installation screen? Also no, the installation screen is not part of your application, so you don't have to make a mention of it inside your manifest file. All right, so why Android applications can't be compiled with the JVM? I'm not sure what the question means, because you're not compiling them with the JVM, you're running them on the JVM. So you use the Java compiler to compile Java applications. Okay, so I hope the question has been answered correctly. Is it possible to make console applications with the Android JDK? Well, the point is, even though we talk of a console, it is supposed to be an activity. I mean, more or less, it is. Yeah. So if you have an application that is going to run inside a browser, it is called a web application. But if you have an application that's going to run outside of a browser, that is, it runs as a native application. So in that case, it is not a web application. Okay. So that is where Adobe Air comes in, right? So I was thinking, yes, I think the understanding is correct. So that answers the question there. All right. Then what is the difference? Okay. Are native applications platform dependent? If you meant the hardware, yes, there is a certain prerequisite that has to be met in terms of the platform. All right. Okay, the Android.mk file is automatically generated. No, it will have to be created manually. So you'll have to make sure that you create it manually. It's a standard format. You can actually take one of the sample projects from the NDK. The NDK actually gives you a set of sample projects, so you can get hold of the MK file from one of those projects, and you can include it in your particular project, and then you can customize it. It's pretty straightforward. It's not very difficult. All right. So can we build an Android app that works on iOS using Flex Developer? Well, it wouldn't then be an Android application. It would actually be a Flex application. Okay, so let me correct the misconception there. So it would no longer be an Android application, but because it's not being deployed on Android as such. It is in fact a Flex application. So you can actually have a Flex application which you deploy onto iOS. All right, so will Android version 2.2 applications work on 2.3 or above? Yes, it is forward compatible, yes. Okay, we need to install Android NDK. Yes, Android NDK, if you remember from the checklist, the third slide which I displayed during the webinar, yes, the Android NDK is a completely separate download. So it's not packaged along with the SDK. So the SDK is one download, the NDK is another download. Okay, so make sure that you're pretty clear. The NDK is a separate download. Okay. All right. So does a Flex application also use the same programming model containing activity services? Yes, deep down, yes, that is the case, but there are some higher level concepts that are very specific to Flex. So those concepts have nothing to do with typical Java applications. Okay, so deep down, it is in the end the same programming model for any Android Java application, but as I mentioned, some things are specific to Flex. Okay. Please refer me some sites to study Android Flex. Okay, I think this we can take it further at a later time. All right, so if the questions are done, I think that should be the end of the webinar. So I thank a lot. I thank TechGig. I thank all the people who have joined us today. I hope it has been a good experience, and I thank you all once again for giving me this opportunity to present this webinar. So thanks a lot.
A few more questions are shared with you. You can go ahead.
Yes.
Thanks, Dr. Subramanian, for your informative session on developing Java, Flex, and native application in Android. It was indeed an enlightening session. I would also like to thank the participants for their support in making this webinar a huge success. The recording of this webinar will be available on TechGig.com by tomorrow. Gentlemen, the next session in TechGig webinar series will happen tomorrow at 3 p.m. Topic of the webinar is the biography of Steve Jobs, the man behind ThinkDifferent. Through this webinar, TechGig will be paying tribute to late Steve Jobs, co-founder Apple Incorporated, on his 50th birthday. So see you all at 3 p.m. tomorrow. Thank you.